Who still remembers? Please don't use this to just say your things. Just ask questions from the chat box. Yes, Bwide.
Phototropism.
Okay, Bwide is saying phototropism. Maybe phototropism would go for B because photo means light. So you can see light is the one influencing growth here. Okay. Yes, Bbumba.
A is geotropism.
Thank you very much. Yes, this is geotropism, and you can see that this is negatively geotropic. That is the shoot. So this is where we had ended, and we had also looked at some of these. So today we expound more much on what we call phototropism. Now, with phototropism, just means so. Please mute so that you can hear me and join with your audio on. If the admin can help me mute these people, I'm trying to. Okay, let us continue with phototropism. Photo means light, and tropism is a growth response. Okay, now when you combine the two words, the growth movement or response of part of a plant in response to a unidirectional light, that is phototropism. And what is going to influence this growth response, what we call auxins. Okay, so these auxins, you can call them plant hormones. Of course, there are quite many, but for us, we shall group them as auxins so that we can understand them well. Now, you're going to see that here there is going to be light coming from one direction. Now, if, for example, you are having sunlight, I'm assuming this is sunlight that is overhead, this plant shoot. Now you find that the auxins in the plant shoot are going to be evenly distributed. You can see these small dots are representing auxins. So they are evenly distributed, and you can see it there. Okay. Now, when the sun is in a given direction, let's say here, you can see, you find that this sunlight is going to be shining on the part of the shoot on one direction. Okay, so what is going to happen is that the auxins, instead of being evenly distributed like here, they're going to move to the dark side. Now light is coming in this direction, you can see, but now the auxins are moving to this other dark side. So now, once they move to this dark side, there's going to be a high concentration of auxins. Okay, now a high concentration of auxins on the side with little or no light is going to increase cell division here. So now the cells in the shoot which are on this dark side are going to elongate and divide more often. Now, the moment they begin elongating, they elongate. Now they're elongating more than this other side, which is more light, which is receiving more light. You find that the shoot is now going to bend towards light. The shoot is now going to bend towards light. Now, this causes the shoot to bend towards light. So that is how auxins normally bring it about. Whether you have a question?
Pardon.
I have said that when the sun is overhead, that is just above the shoot tip, that is the upper part of a seedling, it influences the auxins to be evenly distributed. That is, they are almost everywhere in the tip of the shoot, as you can see here. But when the sun is in a given direction and then light is shining on the part of the tip from a given direction, it's going to make the auxins to move to the dark side where there is no light. So no light here, no light. So the oxygens are going to accumulate here and run away from the lighted side. Now that is going to make this dividing more often, and then it's going to elongate. So you're going to find that this part is going to begin dividing and dividing and dividing and dividing. Now you find that this thing is going to bend towards the light. And that's how normally these plants behave. Now this is a simplified form that you're having a root tip. You can see that light is shining on this side. Now the oxygens run away from the lighted side to the dark side. Now once they accumulate on the dark side, they are going to make those cells on the dark sides begin dividing more often.
Excuse me, sir.
More often than the dark side cells, than
Excuse
the light
me, sir.
side cells. So they divide. Yes, please.
Yes. What are actually oxygens? Like, I don't understand what the oxygens are.
Okay, thank you for that question. For some of you, I think maybe you did not attend last time's lesson. Now, to tell you what oxygens are, let me write the word oxygens. Okay. To give you just a brief background for some of you have just joined us, is in nature, all organisms must respond to stimuli in the environment. Stimuli, those are things which cause you to react to the environment, like the sunlight, the wind, okay? Now, animals, we as animals, we have what we call a nervous system. Now, when you touch a hot object, like you as a human being, you're going to remove your hand because it is burning you. You have a nervous system that detects, and then it makes you to, okay, please mute your things, you're interrupting me. So a human being, you're going to react by when you've touched a hot object by removing your hand, okay? Or when it is dark, you may decide to go and let's say sleep, like you're responding to nature. Now, plants don't have a nervous system, but then how are they going to survive in the environment and then they respond? Now, imagine you're a plant, you are a seedling, and then they drop you in some dead trench, some dark trench. But then for you to survive, you need light, which is the other side of where you're not growing from. So that means you must get a way of growing to where light is. And that's where oxygens come in. Oxygens, you can call them to respond to stimuli in the environment, okay? So those are what we call oxygens. Now, those oxygens are normally produced in the tips of the seedling. I'm assuming this is the bean seed, and then it is germinating to have that shoot, and then the radicle, okay? Now, the oxygens are actually produced in the root tip. We shall have actually have to have those experiments that explain all prove that actually oxygens are produced in the tips of the shoot and the root. Now, those are what we call oxygens, plant hormones. Now, in order to respond to what we call phototropism, photo means light, tropism is a growth response. Now, light is going to be shining on the, now oxygens are going to run away from that side and they go to the dark side. Now, what do oxygens do that make the plant to grow? They're going to increase cell division where they have gone in the shoot. And you find that this dark side is going to divide more often, and then it's going eventually to bend towards light. Now the plant begins growing in the direction of light. Okay. We can now, I think you have understood. Now we have an experiment to show the effect of unidirectional light on growth of the plant. You'll need two potted plants. Then you'll need two opaque boxes. Opaque means something which cannot allow light to go through it. And then a clinostat. Now, a clinostat is a machine that that has a motor that rotates the plant, and then a small razor blade. Now, you will need two boxes, two opaque boxes. So, in one opaque box, you shall put this plant, this potted plant. A potted plant is not like a special plant. It's just a, you know, those. What happened?
Pardon.
You have a question?
No.
Pardon on what?
From the start of that.
Okay. We are looking at an experiment to show the effect of unidirectional light. Now, unidirectional light means light coming from a given direction, like here. I'm assuming this is the light. Okay. So light that is coming from here going to enter. So light can only enter via this small hole. Okay. Now what happens is that okay. So what happens is that you place one plant here in this box, and another one, you can get another box, and again you also place there another plant. Now one plant is going to be placed on a clinostat. Now this clinostat is going to be rotating. It's said that as light is entering through this hole, all the sides receive uniform light. Okay, but then this plant is not rotating, and it's going to make the plant grow towards light, and it follows the same principle of auxins. Now, if I can show you this small experiment a little bit. Okay. I hope you. Now I want you to just follow this this experiment a little bit.
Geotropism. In order for equal distribution of auxin in a plant assembled to a horizontal
Are you
mechanism.
able to hear the sound?
Yes.
Yes, sound clear.
Yes, we are here clear.
Okay.
It is rotated 4 to 5 times per hour. In this case, the plant that has waited for 2 days is seen to be grown with no bend. When a plant is left horizontal to the ground for 2 days, auxin piles up at the stem's lower section. Due to the accumulation of auxin, the cells at this site reproduces further. Consequently, the stem is seen to be growing upwards against gravity. Stems display negative geotropism against gravity. The large amount of auxin that accumulates at the lower part of the root of the same plant inhibit cell proliferation at the lower part. Because too much accumulation gives growth-stopping effects. In this case, the cells at the upper part of the root multiply normally. Thus, the plant root is observed to be grown towards gravity. Plant roots display positive geotropism against gravity.
Okay.
Geotropism.
Now, what you are seeing here is
In order for
clinostat.
equal distribution of auxin in
if you can see it being played,
a
can see
plant
that-
assembled. In order for equal distribution of auxin in a plant assembled to a horizontal
so I
mechanism,
think
it is
you
rotated
can see
4
how,
to 5
a
times.
clinostat rotates. Now, this experiment is for geotropism, which I'm going to explain a little bit later. So that's how a clinostat is going to be like, rotating the plant that is in a box. Okay. And okay, let me
Excuse
go
me,
back
sir.
to the slide. Yes. So in this box, this is how, yes, please.
Excuse me, sir.
Yes, if you have a question, please ask.
Before you go any further, please explain if that plant bends, even the roots bend.
Come again.
If the flowers, as in the they are where the shoot system is, if it bends,
Yes.
even the roots also bend.
Okay, thank you for that question. Now, for now, I want you to first focus on the shoot. And why am I saying that you should first focus on the shoot? You find that it is the shoot. Okay, let me first draw. Now, I'm assuming this is the bean seedling, and it is having that shoot growing up, and then the root is going to be growing down. Okay. Now, because we are looking phototropism first is the growth response. It is the tip that we are looking at first. These roots, we are going to look at how they bend under geotropism, like that video which I've just shown you. Now, for now, just understand about the shoot only, because it is the shoot which normally receives the light, which is up the ground. But the roots will bend due to what we call geotropism, and I'm yet to explain it later. I hope I'm clear on that. Okay. And they normally bend Okay, I hope you can hear me. Yeah. So that is what I was saying. And you need to understand it in bits, step by step, so that we can understand. So we can go to and understand this experiment again. That imagine this box, imagine, okay, if you can't get it clearly here, imagine yourself, you are the plant and you are inside the box, which is dark. I'm assuming you are there and you are a plant inside a dark room with no light. Now imagine there is a small window that is letting in light. And let's say light is shining on your one side of the face. Okay. So when light is shining on one side of the face, if you are a plant, oxygens on that lighted side are going to run away to the other dark side of you. Now, which is not receiving light. Now, what do oxygens have? Now, the oxygens are going to make that dark side, the side that is not receiving light, to begin growing more often. They grow more often, and then this side which is having light is not growing so much. So it's now going to bend towards the light. And that's what actually happens in plants. It is the hormones that make it to grow. But then we normally have a control experiment. That is a control experiment which removes any doubt of this, what you're trying to demonstrate here. And how is that? Imagine you are in here in this dark box that is letting in only small light in one hole, and you are seated on a rotating machine. A clinostat is a rotating machine, and it makes sure that at one moment light is shining on, let's say, this side, but then it is rotating. That means all your sides are equally receiving light through the hole, since you are being rotated inside here, inside the box. Now, once that is happening, so the plant is receiving light uniformly, so the oxygens are distributed uniformly throughout the shoot tip. Now, That is going to make the plant to continually grow upward and upward and upward and upward without bending, because the oxygens are uniformly distributed. It is bending towards light. Okay, it is bending towards light because the oxygens are concentrated on the other dark side since they had run away from the lighted side. Okay, so that is what the experiment is all about. And what do we observe? Now, from our observation, we find that the shoot in A bent towards the direction of light, while in B continued to grow straight upward. Like here in A, this is A, it bends towards light, and for B, it just grows upward. That is the observation. And how do you explain such a result? Light coming from one direction in A made the stationary shoot to bend towards the direction of light. And why is that? Because oxygens, light redistributes oxygens. So oxygens run away from the side that is having light to go to the dark side, and then they increase the rate of cell division on the dark side. Yes, Hasfa Nalvega, you have a question? Hasfa Nalvega, you put your hand up. Please ask. You unmute and then you ask. Maybe the admin, you can unmute them. I don't know whether
teacher, you can tap on that person.
Asfa can ask the question.
Teacher,
yes.
You click on that person who raises the hand and ask to unmute.
Okay. Okay. Yes, you can ask. Nalvega has lowered down the hand.
Excuse me, teacher.
Yes.
What do you mean oxygen help a plant to grow towards light? The dark side to grow towards
oxygens. No. What I mean with is oxygens make where in shoots, particularly in shoots, they make the side where they are, where they have accumulated more often. The cells there divide, and that is what makes it to bend, because this side elongate more than this part, dividing very much than this side. So that's what makes it to bend. Yes, Ibrahim Ali, you may unmute and then ask.
When the oxygens go at the dark side, yes, do the root system also bend? Yes. The root system also bends. Yes.
I say okay, thank you for that question. Ali, what I said is we are now looking at the shoot because we are dealing with phototropism first. Effect in the roots where they have art is going to divide more often than this dark than okay. So I hope Ali, you've understood. Okay, I hope Ali, you've understood now. Then for B, you find that for part B, you find that here the clinostat was rotating and rotating and rotating. So all oxygens were uniformly distributed. Now, that means the chute in B was rotating on a clinostat. All of its sides received equal. And the reason is very simple. Giving light, so oxygens are uniformly distributed throughout the tip. And that is what's going to make it just to continue growing upward without bending. Okay. And in conclusion, the chute responds positively towards light. That is positively positively phototropic. I hope you guys have understood. So if you have understood, I have a small question for you. The question says, when a seedling was placed on a clinostat and placed in a horizontal position, the horizontal position is this one here. That is the horizontal position, okay? The shoot continues to grow horizontally. So imagine this is the plant, okay? And this is the shoot of the plant. This is the shoot of the plant, but then they have placed it on a clinostat. Now this clinostat is the one which is going to be rotating it, okay? So it's going to be rotating it. So the question is, when a seedling was placed on a clinostat and placed in a horizontal position, the shoot continues to grow horizontally. So this shoot is just going to keep on growing towards that direction. But without the clinostat, so if you're having another shoot here like that, without the clinostat, it bends upward. Now this one without a clinostat is going to bend upward like that. This is just placed on the ground without a clinostat. It's going to bend upward. Now, which one of the following is true about the role of a clinostat? Which one of the following is true about the role of a clinostat? Yes. Yes, Emmanuel.
The one that is on the ground, that's the clinostat. Because the axes are all balanced. The one that is bending on the ground with the clinostat, because all the axes are balanced.
So which one would you choose among these options, A, B, C, D?
A, the one that is feeding the uniform light.
Okay. Okay, thank you. Do you guys all agree? So the first one says enables seedlings to receive uniform light. Then B says causes oxygen to concentrate on the lower side of the clinostat. Then C causes oxygens to accumulate on the upper side. And then D says causes oxygens to accumulate uniformly on all sides. Now, this question, if you have noticed it, I thought you would do. Okay, let me first pick someone here to see whether you. Yes, Bbumba, what do you have to say about that question?
D.
Okay. Okay, thank you for that. Now, the reason as why I brought this question, actually, this question should be placed under. Okay, let me first get another person to comment. Yes, Alfred.
It is supposed to be D because the clinostat is going to be rotating and the oxygen is going to accumulate uniformly on all the sides.
Okay. Okay, thank you for that. Let me see this. Yes, but Tracy?
Is C.
Tracy says C causes oxygen to accumulate on the upper side of the seedling. Now, you may lower your hands. Now, what I wanted is I wanted someone to identify something to do with this question. Now, you find that this question is actually doesn't have anything to do with phototropism, because with phototropism, there has to be a light source. You get it? Now, this one, if you can see even how I've arranged this setup, you find that this one has to do with geotropism. Okay, it has to do with geotropism and how it affects tropism. So that's why it would actually be totally wrong when you say that enables the seedling to receive uniform light. That would be wrong, because it has nothing to do with phototropism. So I thought you would get that it was a small trick which I put in this question. But otherwise, if this question had been asked, okay, then you find that D would be the better option. Okay. So D would be the better option, and this question would have to do with geotropism, not phototropism. Okay. What about this question? Says, when a growing shoot is placed horizontally, okay, it bends upward after some time. Which of this one out? I shall come to it when we have understood this geotropism experiment. Okay. Now, geo, earth, tropism is a growth response. Now, with the geotropism, we are going to, first of all, okay, let me first see the sample with their hands up. Yes, Emma, you have a question?
Teacher, I'm not seeing.
Emma, you have a question?
I'm not seeing.
You are not seeing. You may click. You may click in the link again, so that you can see clearly.
Okay.
And then yes, Akim.
Excuse me, teacher.
Yes.
What geotropism?
Come again.
What geotropism?
Okay, you are asking what is geotropism. I think maybe you did not attend last time's lesson, but I'm going to help you with that again. Then there's this one with the Chinese name. Please ask JB something. Okay, if you have nothing to ask, please you lower your hand. Susan, Tatiana, you have a question?
Excuse me, sir, it's JB.
Please ask. Yes.
I'm not
Please
seeing
ask.
anything.
So
now in yes.
Like I was asking about the first question you asked us about the use of the clinostat. So
yes,
you told us that A is not the right answer, and the right answer is C, of which I don't
didn't say C.
understand. No, I mean sorry, D. I don't understand how the D is the correct answer, and why. Why is it the correct answer?
Okay. Okay, thank you for that. I'm going to answer you right away. And then I'm seeing Martha Sparks. Yes, what's your question? Martha Sparks.
Yes, like I wanted to ask the use of the clinostat also.
Okay. Okay, thank you. And then let's end with these two. Namumbia, yes. And then Angela. Yes, Namumbia, what's your question? Gift Monica, what's your question? Okay, I think he's just raising. Let us go to Angela. Angela Molindo, what's your question?
I was asking that I thought the oxygen accumulation only takes place during the phototropism. So even
During
the oxygen accumulation, it only occurs during the phototropism, like for them to increase or reduce to cause growth. It's all about the phototropism.
Okay. I'm also going to respond to you. Let's end with Hasfanal Vega.
Teacher, I would like to ask here on this question. I thought that the answer was A, but you surprised me saying that the answer was B.
Okay. Okay, thank you for that. Now, the thing is, okay, let me, I hope each one of you is able to see what is on my screen. Let me call this, what I've just circled, let me call it experiment A. And let me get another color. Okay. And then, okay, where are you? Let me get another color here. Let's say blue. Okay. Now, for this one, imagine we are having a potted plant. We are having a potted plant, and yes, it is growing like that. And then another one here. Okay, let me say this is the clinostat. Clinostat. And what is it doing? It's rotating. It's rotating this plant. Okay. And light is coming through here. This is the light. And then probably it's in some dark box also. Now, and then on the other side, we are having this plant. Okay. And then you find that it's going to be growing towards light. And then it is having light here coming from this side. And then it is growing towards the light. Now I want you to get these two differences. Okay. Now let me call this one B. Now for B, it is demonstrating phototropism. Phototropism. And for A, it is representing geotropism. Geotropism. Now, what's the difference? Now, in A, when you place the clinostat here, a light coming from a given direction, like at any one time, all sides of the plant are receiving light equally. And remember, light has an effect of affecting the distribution of oxygens in the tip of the shoot. So you find that because all sides are receiving light equally, that means oxygens are, if I can demonstrate here, oxygen distribution. Oxygens are almost everywhere, so the plant is going to keep on growing upward. Now, for the case of here in this other box, you find that light is only coming from one direction and hitting on only one side of the plant. Now, this dark side is going to begin growing more, it grows more, and then the plant bends towards the light. Okay. Now, check this question. This question was saying that when a seedling was placed on a clinostat and placed in a horizontal position, now the plant is no longer in the vertical position here, like here or here. Now we have placed the plant in a horizontal position. Horizontal means, for some of you understand Luganda, nga chebase, like get a plant that you are put in a pot and ochebase and make it sleep. Okay, so that is what the question is asking. Now the shoot continues to grow horizontally, so this shoot, which has been placed on a clinostat, just continues growing nga chebase yade nga chigenda chikula chebase. But then one which was not placed on a clinostat, it begins bending upward because it's not being rotated here. It's not being rotated. So it eventually begins growing upward and upward and upward. So this is what the question is saying. The shoot continues to grow horizontally, but without the clinostat, it bends upward. You can see here it's bending upward. So which one of the following is true about the role of the clinostat? Now for geotropism, in shoots, actually what happens is that gravity has an effect of pulling the oxygens. Okay, let me draw for you this. If the shoot is like this, this is a potted plant. Now gravity is going to pull these oxygens to move downward. Now what do oxygens do in the shoot? They are going to increase the rate of growth in this part of the plant. Okay, let me even put a layer here. Now this layer continues growing faster and faster and faster than this upper layer because oxygens are there, and that is what makes the shoot to grow up and up and up. It's like the lower layer grows up and up more than this upper layer, and that's why I said the question was which one of the following is true about the clinostat. Now the clinostat, if you place a clinostat here, it's going to cause oxygens to accumulate uniformly on all sides, since gravity now has no influence, because gravity would have pulled them here. But when oxygens are here, let's say on the lower side, and you have placed a clinostat, it rotates, and then this side at one time it is the one which is up, at another time this side is the one which is down. So like oxygens are uniformly distributed. Now for A was saying enables the seedling to receive uniform light. Okay, now when you bend here, when you place this this potted plant on a horizontal surface, okay, like it's not going to enable the seedling to receive uniform light. You remember the plant is being bent, okay, and because the question is coming from this background, I hope you have understood. Let me first see some of the comments. Oh, these ones are different. For some of you are saying that you can't hear. Okay. For some of you are saying that you can't hear, please try to you tap in the link again, and then you'll be able to get a proper network. Let me first get this Victory Keys. Yes, Victory Keys, I've asked you to unmute, ask your question. Okay, that one has no question. We go to Isaac. Yes. Ask your question, please. The one having Victory Keys. Tracy. Tracy, ask your question.
So it wasn't a question.
I just want to help you to explain.
Come again?
The pattern. Just wanted to explain something on geotropism.
Yes, please. You can.
It is geotropism because the plants are in an open area, so they can receive light, and they are only reacting to the gravity that is acted upon them.
Okay, that's a very good contribution. Thank you, Tracy. I think you've had Tracy, like, they're not even boxed where they are even receiving already uniform light. Thank you for that, Tracy. And then I'm seeing Mwesigwa Joel. Please ask. Yes, because of time, when you were chosen, you please speak very fast. Don't waste time. Okay, we can leave that. Then there is this one with many numbers. 9 simanya bichi bichi. Yes. Can you ask your question? When I ask you to unmute, you unmute and then you ask your question. If you have no question, then you lower your hand. Yes, Gift Monica.
Master, what I'm asking is that where can we get the work of last time as who have joined just right now?
Okay, it will be shared on Google Classroom. I hope you have already joined there.
Yeah.
And then Ernest.
Thank you, teacher.
Yes.
I wanted to ask, as in, if the plant is placed on the clinostat,
yes,
does it matter where the light is coming from?
Okay, yes, because it will be rotated, and at any time all sides will be receiving light, all sides of the plant.
Okay, I can understand. Thank you.
Okay, and then I'm seeing Donald. Yes, please ask.
Teacher.
Yes.
So on this question we are doing, is D the answer that it causes oxygen to accumulate uniformly on all sides?
Yes.
Oh, thank you.
Yeah, because gravity is not pulling them on only one side, but because it is being rotated, so all sides are actually getting the oxygen, so they are accumulating equally. And let's end with Bombox. I'm seeing someone is called Bombox.
Teacher.
Yes.
How can we access Google Class?
How can you access Google Class? Information is going to be posted in the group, and the admin will even comment about it after the lesson. Okay, let's end with I'm seeing okay, Inorush.
But so what I see, I haven't got a number, but what I see, because if it's placed in a clinostat vertically, it will keep on rotating.
Yeah.
And during that rotation, the seedlings will be balancing.
Yes.
The seedlings will be seriously balancing, then to help them to be moving straight, the plant to be moving straight and horizontally.
Yes, that is
true.
true.
I haven't got it very well.
You have got it very well.
No.
Okay, you can imagine, have you ever put water in a bottle?
Yeah.
And let's say the bottle is not full, eh?
Yeah.
What happens to the water? Does it float up or just on the lower side?
On the lower side.
Now that is the same thing that happens with oxygens when they are placed in this position. They float downward, okay? And once they begin floating downward, they are going to cause those cells which are down where they are to to divide more often, and then they elongate more than these cells which are up, okay? And then the plant begins growing and bending upward. But if placed on a clinostat, just imagine this bottle and you are rotating it. It means that this water is going to be meeting all the sides equally if you're rotating this bottle, not so?
Yeah.
And so they are not going to specifically make the lower cells to grow, but all cells are going to begin growing uniformly. And so the plant will just continue growing horizontally.
I've got you now.
Okay, thank you for that. I'm saying time check. We are remaining with 2 minutes to end the lesson. And okay, there are still more questions. Let me get them. Yes, Tracy, you have Batisachi, Tracy. Okay, you have no question. Let me go to Donald. Donald, you have a question? Please, if I've chosen you, speak very fast and then we. Okay, Kajezi Alex. Yes, Kajezi. Kajezi, Bombox, you may unmute. Kajezi, please.
Excuse me, teacher.
Yes.
This is Victory Keys. So I'm asking.
Yes.
The clinostat makes the potted plant to keep rotating.
That is true.
Oh.
Just like in the other video which I showed you. Okay. I think we end with only one question, and then which other person has not yet asked? Rush.
Excuse me, sir.
Yes.
Sir,
Yes,
please, can you share with us? Can you share with us that video?
Okay. They will be shared in Google Classroom. Okay, thank you guys for everything, and thank you for everything, and I hope the admin can be able to help those ones who have not yet learned about Google Classroom. You can share something with them. Otherwise, let us end here and we shall continue from there next time. And goodbye.
Bye. Well, hey, guys, leave them up. Let's go.
Bro. Man, somebody admin the group. Oh, I'm there, right?